Hi, welcome to DjangoCon 2022, and welcome to this presentation. I'm going to talk about type checking Django code with DjangoTypes and Pyright. I like, when there's working code for presentations, so anyone that wants to can, get the code and slides at this GitHub repo here. And I think the links to the GitHub repo and the slides are also in the description for this talk. Yeah, so let's get started. Python type hints. Yeah, before we talk about type hints for Django, let's just talk about type hints for any Python code. So they were added to Python in version 3.5. And since then, they've kind of spread throughout the Python ecosystem. They're sort of everywhere. A lot of newer libraries these days are just built from the ground up with type annotations in line with the code. For older libraries, like Django, types are often added as stubs. Stubs are files that are separate from the code. They can be bundled in the same repo as a library, but don't have to be. In the case of Django, they're not. There are third-party libraries with type annotations for Django. So stubs are nice because you don't have to touch library source code if you don't want to, which means they can be maintained by the community, and you don't necessarily need to get buy-in from project maintainers to add type annotations to their code. Yeah, there's sort of a network effect with type annotations. The standard library now has like very accurate type annotations for just about everything, and more third-party libraries have type hints. And the more code that you depend on that has type hints, sort of the more benefit you get from using type hints in a type checker yourself. So maybe when type hints were first introduced in 3.5, there wasn't a really strong reason to adopt them, but I think that has changed as the type hints have kind of spread throughout all of Python. Of course, as with everything in engineering, type hints, using them is a trade-off. Adding them to a project is a trade-off. There's, more work up front, but this work of adding type hints helps with correctness, in my opinion, and I hope that'll be apparent when we get to coding with type hints later in the presentation. Helps with documentation. I think code with type hints tends to document itself more effectively than code without, and hopefully that will also be apparent in the presentation. It helps with IDE style features like navigation, refactoring code, changing code, and having confidence that you're not breaking things. And yeah, type hints, if they're configured so that your text editor can take advantage of them, can kind of give your text editor capabilities that used to be exclusive to IDEs. So that's, in my opinion, a plus, and we'll have a look at that as well. So now that we've talked about Python type hints, let's have a look at type hints in Django. Yeah, as I mentioned earlier, Django doesn't have type hints in line with the source code. And there are a number of reasons for that, that are sort of documented by the Django core devs online. One is that type hints, when they were sort of first proposed to be included in Django were a bit immature, and there was uncertainty around like which type checker was, perhaps the best one to use, and which type hint library kind of made the most sense. And another reason is that, as I mentioned earlier, adding type hints to a code base is a trade-off. It definitely raises the barrier for new contributors, and could be seen to raise the barrier for maintainers as well, especially if they're not used to working with type hints. Another reason that's kind of not in this slide is that Django does things that are like difficult to type in some cases. And we'll see that later in this presentation where we have to kind of add some type annotations manually. I think the extra effort there is like well worth the reward, but yeah, having type hints that sort of accurately describe all of the things that Django can do, especially in the ORM, is difficult. Yeah. So what this means is that there are, separate libraries with type stubs that are maintained by the community. And the biggest one, the sort of most important one and the best maintained one, is Django stubs here. And then there's DjangoTypes, which is a fork of Django stubs, and we'll talk about those. And as far as type checkers, in other words, like just a CLI tool that you can run against your code to, on your dev machine or in a CI server to see if there are type errors and where they are. There are a bunch of kind of mature and serious options. The oldest and most canonical one is MyPy. That is sort of maintained by Dropbox. There's Pyright, which is maintained by Microsoft. There's Pyre, which is maintained by Facebook. There's PyType, which is maintained by Google. So a lot of big tech companies here have their own Python type checkers. And this can seem, maybe a little overwhelming. There are a lot of choices. If you're using a language like TypeScript, you use the TypeScript compiler to check your types. There is no ambiguity there. With Python, it's not as straightforward. I'd like to talk a little bit about these different choices and explain why I think some are better than others. So yeah, starting not with the type hint libraries for Django, but with the type checkers, I would go with Pyright. That's the one that I prefer to use for a couple of reasons. One, Pyright is not only a type checker, it's also a language server as part of the language server protocol, which is kind of a spec that's authored and maintained by Microsoft. For those of you that haven't used LSP plugins in your text editors before, this is the part of things that can give like a sort of bare bones text editor like, Vim or Emacs or Sublime Text or whatever, the capabilities of an IDE without all of the cruft that an IDE might have. Yeah, the other point in favor of Pyright is that the author of the library is just a fantastic programmer. He's, even the author of a few type checking PEPs, some of which have been accepted, for inclusion into Python. And the quality of the code base and the tool, I think, are just kind of unmatched. And yeah, if we grant that, Pyright or Pyre or PyType, any of those three are like a better option or an option that we'd like to be able to choose, instead of just choosing MyPy, well, that sort of forces us to use DjangoTypes instead of Django stubs, because Django stubs is only compatible with MyPy. Why is that? Well, Django stubs is, yeah, the best maintained and kind of oldest set of type stubs for Django. When it got started, MyPy was pretty much the only game in town for Python type checking. The other type checkers existed, but MyPy was by far the most mature. And that has changed. They've, sort of all caught up to each other to some extent. And yeah, Django stubs kind of bet heavily on MyPy, and they didn't just create Python type stubs. They created a MyPy plugin, which means there's syntax in there that's like not compatible with standard type annotations, and other type checkers simply cannot use Django stubs. So DjangoTypes is just a fork of Django stubs with the MyPy stuff kind of taken out, so that the type stubs are compatible with MyPy, Pyright, Pyr, PyType, any of the Python type checkers. So that's what we'll use in the presentation today. So now that we have like an idea of what we want to use to add type hints to our simple Django code base here, let's talk about requirements. Requirements are pretty simple. We need to install type stubs as project dependencies. So yeah, we'll use DjangoTypes and Django REST Framework types. Django REST Framework types is analogous to DjangoTypes. It's a fork of Django REST Framework stubs that is compatible with any type checker and not just with MyPy. And yeah, we'll install Pyright and enable it in our text editor, for example, Sublime Text, which is what I'll be using today. And then we'll configure a Pyright config.json file to basically tell Pyright where our dependencies are. We'll install the project dependencies into a virtual env, and we'll tell Pyright where those dependencies are, so it can help us with code navigation, with checking correctness of things, and so on. Yeah, one other thing to mention before we just head to the command line and look at some of this stuff is that if you can be on Python 3.8 and up, that's sort of more desirable for using type hints. They work like without any hitches in previous versions, but the syntax is definitely friendlier if you're on Python 3.8 and up. You can just do this thing here from future import annotations, and then syntax changes that shipped in Python 3.9 or 3.10 or will ship in 3.11 are all available in Python 3.8. And yeah, this just makes things more ergonomic. You can use like the built-in list syntax instead of having to import capital list here from the typing module. You can use this pipe for unions instead of importing union from the typing module, and just other niceties. So yeah, installing dependencies. If I head to the command line here, I've got this project, and yeah, I've already installed Pyright, and I've installed Poetry. Poetry is what I'm going to be using to install dependencies, and I've already run Poetry install to install those dependencies. Yeah, if I run Poetry show-v, Poetry will show me which dependencies I've installed for this project and where it's put them on disk in this virtual env. Yeah, and this is sort of like a minimal set of dependencies. We just want Django and Django REST Framework and the type stubs for Django and for Django REST Framework. If we look at pyproject.toml here, this is where these dependencies are specified. Yeah, so to tell Pyright where these dependencies are, we need to create a Pyright config.json file. I've got this Pyright config-ci.json file. This one is checked into version control, whereas Pyright config.json is not. And that's because if you're working on a project with multiple devs, it's nice that everyone can create their own Pyright config.json and specify their own values for VM path and VM here. We can take those values from what was printed to the console by Poetry Show-V. This here is the VM path, and this is the VM. Yeah, once we do this, if we run Pyright from the command line here, we'll see that we have some errors. We'll get to the code in a little bit, but none of these errors are import errors. Pyright is now able to resolve all of these dependencies. If we hadn't done this, or if we, I don't know, get rid of this code and run Pyright again, we're going to have a whole lot more errors because Pyright can't find our dependencies. Yeah, there are a bunch of like configuration options in this JSON file here. Those are described in the Pyright repo, and they just give you sort of knobs to play with and make your sort of type checking experience sort of more or less strict. Yeah, I tend to think that stricter is better. Okay, so yeah, if I run Pyright again, looks like we're sort of done installing our dependencies here. Yeah, so we're going to add types to an existing project. We've got just 3 models in this project: post, thread, and user. We're going to build something like the world's jankiest Reddit. And yeah, we've got these posts up here that belong to a user. That's what this sort of line with the fork on the end of it means. A user has many posts, and every post belongs to a user. And we can see that we've got a foreign key from post to a user over here. Every post also belongs to a thread, kind of like a channel. Well, I guess if we're using the jankiest Reddit lingo, a subreddit. So we've got like a thread ID pointing to thread. That's a foreign key. Yeah, and then a user can subscribe to threads. So we'll have this many-to-many relationship between user and thread that basically says like a thread can have many users subscribed to it, and a user can be subscribed to many threads. And then we've got this nullable foreign key here. That's what this like dotted line here indicates. We've got this nullable foreign key from thread to user. The thread can have a single moderator that points to some user. And yeah, what we'll do is kind of add type hints to the models, which is a good place to start. We'll get to that in a moment. And then after we've added type hints to the models, we'll kind of flesh out some view code that takes advantage of the type hints. So yeah, where to focus. We'll start with the models. We have to add type annotations for every like foreign key field that ends with _ID. These fields aren't explicitly declared on the model class. They're kind of like added to the model by Django, and this is what I was talking about earlier, where I mentioned that Django has some patterns that make like it difficult for a type checker to or impossible for a type checker to infer what's going on with every class. So some things we have to annotate manually. Yeah, so on the user model, actually on the post model, we would have like a user ID field that we annotate, and just mention that that's an integer. And on the thread, we'd have a moderator ID field, and because this is nullable, we sort of tell the type checker that this is an integer or none. Yeah, another thing that we have to annotate by hand is reverse foreign key managers. If you look at maybe post here, and every post belongs to a user, is authored by a user. That means like a user has many posts, and if we have a user instance in the ORM, we can do user.post.all, for example, to get all the posts that belong to the user. We have to annotate those posts by hand on the user class, and just say that post points to a manager of post instances. Many-to-many fields, sort of the same logic there as with the reverse foreign key manager. This is something that the type checker can't infer, and we have to annotate manually. And then there are some special cases that aren't required, but like we can sort of get more mileage out of the type checker if we give it a bit more information about, I don't know, where we have a car field that is restricted to just a few choices. Instead of having the type checker think that this car field is just a string every time, we can say, well, no, it has to be one of these literal choices, and we'll see that in a moment when we start coding. For views, there's not as much to worry about. We'll get a lot of mileage just out of adding the type annotations to the models. But one thing that's nice to do is create our own request class that inherits from request. We're going to be using DRF here, so it'll inherit from a DRF request. And we're just going to change the user attribute, like on a request instance, so that it points to one of like our users instead of an abstract base user or one of Django's built-in user classes. And if there are places where we're kind of fighting with the type checker, and we know that some code is okay and the type checker doesn't think it is because it doesn't have enough information to know that, we can work around these kinds of errors with cast or this type ignore directive in a comment. We should try to do that sort of as infrequently as possible. If you are ignoring your type checker, it is giving you less value. But there are some places where like there's no other good way to work around things. So yeah, let's just go over to the text editor now and start adding type hints to the models, and then write some of these views. Yeah, so we're gonna start with our models. We've got this base model here that our other models inherit from, and it ensures that every model has like some extra record keeping fields here, some timestamps, and then we'll move down to our user model. User doesn't have any foreign keys to other models, but it does have some sort of reverse object managers. Every post belongs to a user, so a user has posts, and we'll just annotate this and say that posts here on the user points to a manager of post instances. We'll do the same thing for threads. Remember, every user can subscribe to multiple threads, so we'll have threads here, and this will be a models dot many to many field, pointing to thread through the user thread table, which is down here. This is the through table between thread and user. Yeah, a user can also moderate a thread, and a single user could moderate many threads. So we'll have, I guess, a yeah, a reverse object manager called moderated threads. That's also a manager of thread here. And yeah, regarding role, if we look at the type of role, Pyright thinks right now that this is a car field that just has a string inside of it. We can do a bit better than that. We know that the role for any user is either member, moderator, or admin. So we can instead say that this is a car field that points to a literal of member, moderator, or admin. And if we do this, Pyright is going to complain at us. It's still convinced that this is just a car field with a string inside. It doesn't think it's okay that we sort of restrict this value to being one of these three literal values. So here we're going to work around the type checker, and we're just going to tell it not to freak out about this. And now we have a car field whose value has to be one of member, moderator, or admin, which is kind of nice. And if we think we might use this literal type in other places in the code base, well, we can, I don't know, pull it out of here, and we can, call this, I don't know, user role type. And then we can create a user role type that's equal to this. This is just a type alias now. Yeah, so that will take care of things for user. If we look at some of the other fields, you'll see that in email field, the type checker knows there's a string inside there that, that seems correct. And yeah, we can move down to post. So post has foreign keys to user and thread. We'll add a user ID in here because this is sort of some Django magic and can't be inferred by the type checker. We know that this points to an integer. Same for the thread ID. If we look at the type of user and thread, the type of user looks good. It's a foreign key pointing to user. The type of thread does not. That's because we have this kind of syntax here, and the reason we have this syntax is because thread is defined later in the module. So we'll just tell the type checker that this is a models.foreign key with a thread pointing to a thread. And now this type here is sort of more explicit and more correct. If we look at text, yeah, this is going to sort of resolve to a string when we access dot text on a post instance, and is deleted is going to be a Boolean, and that looks good to me. Let's move on to thread. We've got this moderator here. If we look at the type of moderator, it's a foreign key that points to user or none. This is really cool. The type checker knows, because this argument is true here, that this moderator doesn't always point to a user. Sometimes it points to none. We'll add a moderator ID that also points to an integer or none. Yeah, we've got this many-to-many field pointing to users, so we're going to want to add that type annotation as well. Users points to a models.many-to-many field user through user thread. That looks good. Yeah, and that about takes care of things. We're not going to be explicitly using the through table model much here, but we could add a couple of annotations anyway. We could have a user ID, which is an integer, and a thread ID, which is an integer, and we'll sort of leave it at that. I guess worth looking at a date time field. the type checker knows that like this subscribe that really resolves to a date time, which is nice. And yeah, before we get to writing, view code here, we've annotated our models. And before we get to writing view code, let's just write a function that, sends some email notifications to users about threads that they're subscribed to that have had, posts published to them in the last week. So we'll send, in this function, we'll send an email notification to each user with, the text from all the posts in, all the threads that each user is subscribed to in the last, 7 days for posts that were published in the last 7 days. So yeah, we'll start with these threads here. And maybe this is just going to be, thread.objects.all.prefetch related. We want to prefetch the related users that are subscribed to the thread and the related posts. So this is now a base manager of thread. We can iterate over these threads, and the type checker will know what's in this sort of iterable of threads, which is cool. For thread and threads, let's get some posts. Posts could be the post sort of created in the last week equals thread. Type checker knows this has a type of thread, and that's cool. And it knows that it has posts. No, it doesn't. And that's because we haven't added, every post belongs to a thread. We haven't added a reverse object manager for posts up here. So this would be a manager of post. And now we should be good. Cool. So thread.post. Maybe filter created at is greater than the current timestamp minus 7 days. That looks good. And yeah, we want to kind of get the concatenated text of all these posts so we can stick that into an email and send it to the users that are subscribed to this thread. So maybe we'll do that. We'll just say that, text here is equal to, we'll do something very simple here where we take each post and separate it from the next post by a couple of new lines. And we'll pass, post.text or post in posts here. And now we've got a string. This is a post. This text is a string. The type checker sort of knows what's going on. And now for all of the users, for user in, I guess, thread.users.all, this is going to be all of the users that are subscribed to the thread. We will call send email with the user's email and the text. And now the type checker is happy, and the code looks okay. And maybe we'll do a better job up here with send email. We'll annotate this function as well, and we'll say that email has to be a string and text has to be a string. And then if we pass something like user.id into here, the type checker would tell us like this is not okay because int is not compatible with string. It's not assignable to string. But email is. So we're good. So that about covers things for our models module here. And let's head over to the views. We're just going to write some view code that takes advantage of the type hints we've added to the models. The first thing I want to do is just create this user request type. If we look at self.request in here, because we've installed type stubs for DRF, type checker knows that this is a request instance. And if we look at the user, this is an abstract base user or an anonymous user. But because, the only users that can hit this view have to be authenticated, we kind of know that it's, once we're in here, like this user is one of our users. So let's just improve things slightly by creating a user request class that inherits from request and is identical to it in every way except that, the user attribute doesn't point to an anonymous user or an abstract base user, it points to one of our users. So yeah, that's our user request. And now we can annotate this view class here so that, self.request always refers to a user request and not a regular DRF request. And now this guy is a user, and that means they'll have attributes like email, created at, and so on. And this is kind of nice. So yeah, let's start with this first view here, user post list create. We're gonna list all of a user's posts or create a post for this user. And yeah, we're going to assume we have like a real serializer class lying around here somewhere, but we're not going to do that in this presentation. So we just want to list a user's post. I guess we can, return here post dot objects dot filter. Maybe the user that created the post is equal to self.request.user. That looks good. Yeah. And if we want like some extra safety, this is not necessary, but if we want some extra safety, we can tell the type checker that it should always expect get query set here to return a query set of post instances. And then if we, do something else like, I don't know, return user.objects.all, type checker will tell us that's not okay. Yeah, a manager of user is not, assignable to query set of post, whereas a manager of post is assignable to a query set of post. So we're good here. And yeah, when we, perform create here, yeah, it looks like this here needs to be a list create API view and not just a list API view. And yeah, I'm going to just jump into the source code. This is another nice thing about having Pyright know where our dependencies are. It can help us look up code definitions and navigate the code more easily. So I'm just going to jump over to this list create API view class here. And if we, look at this class, we can see that it's in our virtual M up here. So yeah, Pyright is resolving the dependencies in the virtual M. Yeah, we have this list create API view. It has this create model mix, and this has perform create. And it looks like perform create just calls serializer.save. So that's kind of all we need to do in perform create. But we're going to kind of set the user to being self.request.user when we call serializer.save. And that's just going to ensure that this post is created by the user that just hit this endpoint. Yeah, and it looks like this endpoint is sort of finished now, and we can move on to this one here, post retrieve update. So yeah, in perform update here, we're just going to call the superclass to perform update on and pass the serializer in. But we want to make sure that a member can only update their own posts. A moderator can update their own posts or posts in any thread they moderate, and an admin can update any posts at all. So let's get the post from this view. We'll have this post, which has a type of post, and this will just be equal to self.getObject. So we've got a post now. And maybe for ergonomics in the view, we'll just assign self.request.user to a user variable. So we've got user equals self.request.user, and this thing has a type of, oh no, it has a type of abstract base user, anonymous user, and the reason it has that type is because we haven't specified that the request in this view is a user request. And we'll go ahead and just do this for our other view classes right now as well. All right, so now if we look at this user, it has a type of user, that's good. And if user.role is equal to normal, oh, what do I do here? Yeah, this is the type checker helping us out again, because the role has to be one of member, moderator, or admin. It'll tell us like that this comparison here is not valid. It's not going to raise an exception at runtime, but it's certainly a mistake on the part of the programmer, because this is always going to evaluate to false. You may as well just write if false here. So if the user has a role of member, if I guess the post.user is not equal to this user, then we'll raise an HTTP 404 before we ever call perform update on the serializer, and this user just won't get to do this. If we look at the type of post.user, it's user. If we tried this kind of comparison, the type checker would tell us like there's a problem here, like this also is always going to evaluate the false. These guys don't have even the same like class, so it's got our back there as well. That takes care of the case when user.role is just member, and if user.role is equal to moderator, and I guess a moderator can update their own posts, and they can also update the posts in any thread that they moderate. So if it's not their post and it's not a thread that they moderate, so I guess we would do post.thread.moderator is not equal to user, then we've got a problem, and we'll do the same thing. We'll raise an HTTP 404. And yeah, if the user role is an admin, if the user role is an admin here, then we're good. We don't have to do any checks. They can just update any post they want to. Yeah, and then we'll add views here for, it looks like we haven't imported this. So that's kind of nice. The type checker will help us auto import things, and even sort of order them alphabetically to the best of its ability. Not as well as isort, but it does a pretty good job. So let's say we want to have this view where a user can subscribe to a thread. We just want to basically sort of add a through table record in user thread to establish this many-to-many relationship between user and thread. So we'll just yeah, maybe we'll get this thread here that has a type of thread, and this could be equal to self.getObject, and then we'll add the user to the thread. And if we tried to add like 10 here or something, the type checker knows what we can add to a thread. It's kind of cool. 10 isn't compatible with user. It knows that we've got to add a user in here. And to unsubscribe from a thread, we just need to remove a user from a thread. So looks like this code is going to be almost identical. Yeah, and that should take care of that. Yeah, so that about covers it. Now we've, kind of written some very basic views here and seen how the type checker can help us, catch mistakes, autocomplete code for us, look up definitions, in the libraries we depend on, navigate through the code, and so on. So yeah, let's head back to the slides here. That brings this presentation sort of to a close here, and I want to just recap some things. Starting with, in my opinion, at least, type hints are great, and the bigger the project, the better they shine as projects get bigger and have more developers working on them, because they help the code document itself and help you catch bugs at sort of like compile time, really type check time, instead of like having to catch those bugs in your tests or maybe like catching them in production. Yeah, it would be really great if the canonical type stubs for Django were in this Django stubs library, because the community there is kind of bigger than in the DjangoCon library, although the maintainer of DjangoCon is just fantastic. Yeah, I don't know if that'll happen, but that would be nice. And whether or not that happens, it would be great if type hints could eventually be added to Django proper. They don't, have to be in line with the code. To a developer that's just using Django as a dependency and not like, developing Django themselves, it makes no difference whether the type hints are in line with the code or whether they're in like a stubs file that, kind of lives in the same repo. Yeah, it would just be sort of one less dependency. You wouldn't have to like choose between a library like Django stubs or DjangoCon or anything else. If you, depended on Django, your type checker would automatically resolve the type hints for the library. And I understand like why the core devs decided not to do this in the earlier days of Django type hints, but I think some of the sort of obstacles have become smaller, and the situation has improved. There's sort of less uncertainty in the Python type annotations ecosystem. The syntax is kind of mature and not nearly as clunky as it used to be. And because of that, it may even prove to be the case. It certainly proves to be the case in code that I write, that like adding type hints, to the code, even though it imposes this upfront cost, makes development easier. I, kind of add type hints to any code that I'm writing these days, unless it's like a really small one-off script that I'm going to run in IPython to check something out, because it just makes things, it makes things faster. And yeah, the burden wouldn't be huge because, the community with libraries like Django stubs and DjangoCon has done a lot of, the heavy lifting already. Yeah, so that will really bring this to a close. And I just want to thank everyone for tuning in and watching the presentation. Yeah, a little blurb about me and where I work. I work at Elementary ML. We do machine vision and machine learning on IoT connected devices. And we use a lot of Python. And if you, check out our site and you think it looks cool and you're a fan of Python, it would be cool if you got in touch. Thanks again for watching, and, enjoy the rest of DjangoCon. Bye-bye.